And welcome back to the another interesting session of your CCNP ENCOR training. So in this training, we are going to cover up some your it's one of your security part as well. So this is like a very interesting topic to understand. So basically, the topic which we are going to discuss as of now is known as COP. So you might have heard about this term COPP. So whenever I describe the COPP, so this basically it stands for control plane policing. So guys, like whenever we are talking about this COP, so this COP is something this is something control plane. So before understanding this control plane policing, so we need to understand the first term, like the first thing, like we need to understand what exactly this control plane is. So if I'm gonna write about the control plane to make sure you understand, so let's write control plane. So in this control plane, the thing is it deals with the traffic. So we can write it deals with the traffic which is destined to network, which is destined to network or source from any networking device. Or we can simply write any network device. So this is what basically the control plane is. So like guys, you might have heard about the terms control plane, data planes, management plane. So this control plane is it's one of them. So whenever we are talking about the control planes, so there are possible threats related to the control plane, like how we are going to prevent those threats possibly. So let's take one simple scenario to understand. Let's say that I have two routers, like this is my router one and this is my router two here. And both of my routers are connected with each other. Once two routers are configured together, like once two routers are connected with each other, so definitely they are going to generate some kind of traffic. So let's say this router is going to generate some hello traffic, right? Hello, and it is configured with some, let's say EIGRP. And both of the routers are connected. So, basically it is about building the database like routing table. So we can say building the database. Now, what kind of database here I'm referring to? The database here I'm referring to is your routing tables and your forwarding tables. So these are two types of, basically we can say databases. Just make sure to understand. So it is all about by building the database like routing table and forwarding table. So for what it builds these database, so it builds these database for the data plane, which is considered as packet forwarding as well. So this control plane information has to build where and how to forward the packet. So we can simply write control plane whenever we are describing, like it's something which I'm writing to make sure you understand in simple terms. So control plane information has to build where or how the packet forwards. So this is why we need this control plane, where and how the packet forwards. So this is what basically your control plane is. So like here, whenever I'm talking about this control plane, so the traffic can be any type of traffic, like it can be routing protocols, it can be IGMP, it can be PIM, it can be, NHRP, ICMP, V6 traffic. So all these are some, kind of your uh, traffic types of traffic we can say. So like guys, one more thing to add here, there are possible threats to the control plane. Now, what are these possible threats? So just let me write here possible threats. So if I'm saying this possible threats, so one of the possible or one of the major possible threat we can say it's denial of service. Now in this denial of service, how it can happen? Like routing protocols, we can say, let's say routing protocols are receiving the false routing updates. So we can say mismatch of configurations like mismatch of timers. So it can cause, effect on the CPU of that particular network device if you are receiving, false routing updates. So this is one of the threat. So attacker can send many packets. So we can write attacker can send many packets to CPU. Why? To make it slow. So this is what basically, the control plane is like, these are some possible threats to your control plane. So to make sure all these, control planes to prevent all these possible threats, some relevant solutions were created. Now the solutions were what? So in the solutions, we do have like we come up with something very pretty much interesting, which is routing protocol authentication. Routing protocol authentication. So this routing protocol authentication, like it supports the authentication for like AIGRP. So we can write AIGRP, OSPF, and after OSPF, like ISIS also supports authentication. BGP is one of the protocol which supports authentications, and like RIP version 2 is also going to support the authentication. So router authenticates the source of each routing update packet that it is going to receive, like exchanging of the hello packets, like the password mismatch and all. So everything should be there. Now this authentication is of two types. So we can write here authentication types. Now, whenever I'm talking about the types of authentication, it's pretty much simple. The first thing we have is the simple password. Simple password, like it will be in the form of clear text. It will not be, uh, encrypted. But the another version we do have is the MD5. So this MD5 is something which is, we can say the type of password which is in the encryption form. So any other user will not be able to, see your password. So it is MD5 is always encrypted. So this is what basically your solution is. But there was one more solution which we came up with, and that solution was like your CoP, control plane policing. Now, whenever I'm talking about this CoP, so basically it is a method we can write in the start point. It's a method of permitting, dropping, and setting the rate limit. Rate limit here I'm referring to, like it is something like how many packets, like how much amount of packets per second you should send to the CPU. It can be either inbound or it can be outbound. So we have already discussed the kind of possible threats in the last slide, like how it is going to affect. So if there is a kind of attack on the control plane, it is going to affect the management plane and the data plane as well. So, we can try to understand with an example. So let's say that we do have this kind of scenario. We do have this control plane. Then after control plane, we do have some management plane, which is going to manage the sessions, management plane. And lastly, we do have some data plane. So if I'm going to, explain you this plane, so like you will get a better understanding in your automation part about all these things. Like what is control plane, what is database plane, and all these things. You must be having some basic and good idea about what exactly this control plane is, what exactly this management plane is. So this is how it is going to work. So here in this control plane, like, we can say the routing protocols are there, or we can say IP routing is there. So these are the things which are done here in the data plane, like, the incoming packet comes like this, and it is going to look in the IP forwarding table. We can say IP forwarding table, and then it is going to get out of that outgoing IP. That IP, like the incoming packet will go via the outgoing IP interface using that particular interface. So let's see how this control plane policing is going to help us in restricting the attacks, because as we have discussed that this is a part of security. So we need to understand the thing is that how exactly this CoP is going to give you the basically how it is going to help you with restricting the access. So let's say by using CoP, we will do like, let's take one more example to understand CoP. So let's say this is my router and this is my router, and I have divided this router into three options. Let's say we'll divide this router into three options, 1, 2, and 3. Now, what are my three options? The first one is always your interface, from where the data is going to came in or from where the data will be going off. Now, after the data, like, whenever we are talking, so like the first thing we have is like, let's say we have some interface here. Let's assume 00. This is 00 is the interface, and my traffic enters and exits on the other side. Like this is the exit interface, or like, we can assume that from here the packet will in and from here the packet will go out. But before that, between the in and out process, like when the device receives the packet, what it process, how it process, and where it sends. So once the traffic enters into my device, it directly goes to your interface, because over the interface you are going to receive. Now, after receiving over the interface, you will find that the data will reach on the control plane. Now, after the control plane, so by default, like if the traffic is going to enter into the control plane, by default, if you have not applied any kind of limitations on the control plane, the traffic hits the interface and then it sends to the CPU here. So, and the CPU will process it, and then if it is permitted, it is going to allow that to this outbound interface. But the traffic is not allowed. Let's say if you are going to access some telnet traffic which is not allowed. So what is going to happen? Like the telnet traffic will come via the interface, it will reach via the control plane, and then CPU will process that is it allowed or not. So accordingly, CPU is pretty much involved here. So how we are going to make sure that CPU utilization will be very low? So we will implement some policies on the control plane, which means like we will do some kind of rate limiting in this kind of scenarios whenever we are doing. So let's take one scenario. Let's say we have some router one here. This is my R1, and this router one is somewhere connected to some BGP, or we can say some service provider network. And this R1 is here connected to your R2. So now guys, if you will see that router one is connected to the service provider BGP, also configured with some internal routers using some EIGRP here, let's say. So in this EIGRP part, guys, like, we can say that, let's say 100 packets per second matches the EIGRP condition. Like if I put the condition here, like if we can apply all these things here. So if we are receiving more than that, which means it can be an attack. So we will tell the router to actually drop it. So what we have done is now that traffic enters the interface and then it will reach the control plane, and control plane interface, under the control plane interface, it will find that like the rate limit or whatever the configurations or whatever the restrictions you have configured. So like this is how it is going to immediately stop it if the packet rate is more than 100 packets, right? Because we have already set for EIGRP 100 packets per second, right? So this is my condition. So any specific services can be dropped, any specific services can be allowed depending upon the types. So our main motive here is to protect the CPU from being overloaded by an unnecessary traffic. So that is what we do here in this COP, which is control plane policing. Now, when we are talking about the configurational part of control plane policies, it's pretty much simple. But before understanding the, control plane policing, so let's write some points here. CoPP, which stands for control plane policing. Now, this policing is the term which is generally used in quality of service, which here refers to the restriction. Now, the configuration wise, like if we are talking about the control plane policies, so we will be doing the configurations by using some class maps. There are some policy maps, and these kind of services are implemented in quality of service, like in ASA firewalls, zone-based firewalls. So if you will see how hierarchy goes to, configure this feature of COP. The configuration wise, like first thing we need to do is we always need to create one class map. Once class maps are created, then we will apply some policy maps, and after the implementation on the control plane. So this is what basically we do in this for CoPP, which is control plane policing. So like let me explain separately. So if you will see that like these class maps are used to match, like I'm talking about this class maps, these class maps are used to match the traffic. Like, you want to implement some kind of policy for EIGRP traffic, like, we need to match this EIGRP traffic that maybe you want to match any specific source or destination, or for, selected source or destinations. So class map tells you what traffic we want to match. And the next we use is the policy maps. So these policy maps are simply going to let you know that, what to do with that particular traffic, like what action needs to be taken. So let's say if we have multiple options, so such as action should be like, if you want to allow, if you want to drop, if you want to put some policies, if you want to give some rate limit, or in quality of service, you will find more options in the zone-based firewalls, or like, you have other options to inspect like that. So finally, we apply this policy map on the interface of that particular control plane, or in the even in the sub interface of the control plane, we can say. So this is what basically your control plane policing is. Now we will see a quick lab scenario to understand how exactly this COP works.